Okay, so you're using a computer right now, right? But have you ever really stopped to think about what's actually going on inside that box or that phone in your hand? Today, we're going to demystify it all and get right into the fundamentals of how these things actually work. Here's the plan. We'll start with the biggest question. What even is a computer? Then, we're going to metaphorically crack open the case and look at the key parts inside. After that, we'll zoom way in on the computer's brain, and finally, we'll see how that one simple design is the blueprint for basically every computer out there. Sound good? Let's dive in.
All right, first things first, we have to start at the very beginning.
Now, this seems like such a simple question, doesn't it? But the answer? Well, it gets to the very core of what these incredible machines are all about. So here it is, the big idea. A computer isn't just a fancy calculator. Nope. At its heart, it's a machine that's just really, really good at following instructions. Its whole job is to take raw, messy data and turn it into something that actually means something to us. And you know what's crazy? Every single computer, I mean from the monster supercomputers down to your little smartwatch, follows this exact same simple four-step cycle. You might hear people call it the IPCOS cycle. Just think about writing an email for a second. When you type on the keyboard, that's the input. The computer taking your letters and formatting them, that's the process. Seeing the words pop up on your screen, that's the output. And when you hit save to drafts, yep, that's storage. That simple little loop is literally the heartbeat of everything a computer does. Okay, so that's the idea, the theory of it all. But what about the physical stuff? What parts actually make that cycle happen? Well, let's open up the machine and take a look.
Turns out, it's not as complicated as you might think. Every computer system, no matter how big or small, is basically built from just these four essential types of hardware. And each one has a really specific job to do in that IPOS cycle we just talked about.
So first up, input devices. Super simple. These are all the tools that let us, the humans, talk to the computer, to give it data and tell it what to do. They're our bridge into that digital world. And you use these all the time, right? Your keyboard, your mouse, that scanner in the office, the microphone for your video calls, even tapping on a touchscreen. If you're using it to put information in, it's an input device. And of course, on the flip side of that, you've got your output devices. These are the pieces that take all that processed information and show it to us in a way we can actually see, hear, and understand. This is everything from the images on your monitor to the paper coming out of your printer or the music coming through your speakers. It's basically the computer talking back to us.
All right, next is memory, and this one's really important. There's a big difference here. The best way to think about it is this. RAM, or primary memory, is like your desk. It holds everything you're working on right now. It's super fast. Your hard drive, or secondary memory, is the filing cabinet in the corner of the room. It's where you put stuff for long-term, permanent keeping. You need both, because the desk is blazing fast but gets wiped clean when you turn the power off, while the filing cabinet is slower but remembers everything forever.
So what's the one component that actually uses all that memory? The part that does all the thinking, the processing in our IPOS cycle? Well, that would be the brain of the whole operation, the CPU, the central processing unit. So let's zoom in on this brain. Let's see what makes it tick, because this is really where all the action is. Inside that little chip, you've got two main parts working together. You've got the arithmetic and logic unit, or ALU. That's the master calculator. It handles all the math and all the logical comparisons. And then you've got the control unit, the CU. Think of it as the project manager or maybe a traffic cop. It grabs instructions and directs the flow of data, telling everyone else what to do and when to do it. Now, to move at those incredible speeds, the CPU has its own little secret weapon, tiny, lightning-fast memory spots called registers. They're built right onto the chip itself. They're like little sticky notes the CPU keeps on its desk for data it needs right this second, without wasting time going all the way to the main RAM. Okay, so now we get it right. We've got our four-step cycle, our four key components, and the CPU running the whole show. So let's zoom back out and see how this one simple recipe is used to build the entire family of computers. And this just shows you how flexible that basic idea is. That same fundamental blueprint powers everything, from massive supercomputers trying to solve the mysteries of the universe to the laptop you're using, all the way down to the tiny, specialized computers hidden away inside your car or your smart TV. And what makes them all so powerful? Well, it's this combination of things. It's the insane speed, the pinpoint accuracy, the ability to store just unimaginable amounts of information, and the fact that they just don't get tired. They can do the same task over and over perfectly, which makes them useful for pretty much anything. So let's wrap this up. We've seen that every single computer, big or small, just follows that simple IPOS cycle. It uses those 4 key types of hardware, and the whole thing is run by the CPU, the brain in the machine. It's that simple and that powerful. This basic architecture, this simple idea, it's not just in a computer case anymore. It's in your phone, it's in your car, it's on your wrist. It is absolutely everywhere. So the only question left, really, is where are we going to put it next? Thanks for watching.